Welcome to Nihal Academy. This is your physics mentor Pavan Kumar. Today we will discuss a small topic, parallel connection of resistors. So when we connect the resistors in parallel connection, then what about the total resistance? Here three resistors R1, R2, R3. Here these are connected in parallel. So what is the parallel connection? This is the first end of the first resistor R1. This is the first end of the second resistor R2, and this is the first end of the third resistor R3. All these first ends of the resistors R1, R2, R3 are connected together here, and it is connected to the positive of the battery through ammeter. Now come to the point here. This is the second end of the first resistor, and this is the second end of the second resistor, and this is the second end of the third resistor. So all these second ends of the resistors R1, R2, R3, they are connected together here and connected to the negative of the battery through plug. And potential difference battery is V. So when we close the circuit, current passes through the circuit. So we can understand the total current passing through the circuit by using ammeter. When current comes to the junction here at this point, it splits into the three parts. Some amount of current passes through R1, and some amount of current passes to R2, and some amount of current passes through the R3. And finally, the resultant current, when it comes out, the output current, it is equal to the total current I. And these three resistors are connected at the same potential difference V. It is equal to the potential difference at the battery B. So here we can understand that the potential difference at the three resistors is remains constant, and current variates because current is splitting at the junction. So due to the parallel connection of R1, R2, R3. So here potential difference is constant and current is variating, so changing. So here current is variating, so current is splitting, so we can write the total current or net current I. It is equal to the sum of the current passing through R1, R2, R3. So that is I1 current is passing through R1, and I2 current is passing to R2, and I3 current passing through the R3. So the total current I is equal to I1 plus I2 plus I3. Understand? Now we know that as per Ohm's law, V is equal to IR. From this, we can write I as a subject, that is I is equal to, if you send to R that side, then it will become divisible. So V by R. So I is equal to V by R. If you substitute this value here, then instead of I, we can write V by R is equal to, then I1 means I1 amount of current passing through the resistor R1, and it is at the potential difference V. So V by R, it is equal to R1 plus I2 current passing through the second resistor, that is R2. Here the potential difference is V, so V by R2 plus I3 amount of current passing through the third resistor R3. Here R3 at the potential difference V, so V by R3. Look here V is constant, V by R1, V by plus V by R2 plus V by R3. Here V is constant, so we can take out V as a common. So V into 1 by R1, V taken out, then 1 by R1 is left here, plus V is taken out, then 1 by R2 is left here, 1 by R2 plus V is taken out, then the left term is 1 by R3. So this is equal to V by R. Here either side of the equality symbol, V is constant, the same value, so we can cancel V. Then 1 by R, it is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So this is the final resistance or resultant resistance or equivalent resistance in the parallel connection. So parallel connection, so we can write here P. So when three resistors are connected in parallel, the resultant resistance or equivalent resistance or final resistance or total resistance 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. If you generalize this equation to the n resistors connected in parallel, then 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3 plus so on plus 1 by Rn. So this is the resultant resistance when n resistors are connected in parallel. So 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3 plus so on plus 1 by Rn. Now we will apply to the two resistors. When two resistors are connected in parallel, there is a resistor R1 and this is a second resistance R2. So when the two resistors are connected in parallel, so all the first ends are connected together and all the second ends are connected together. So the current passing through the circuit is I. The output current is equal to I. And all these two at the same potential difference, that is equal to V, it is equal to potential difference at the battery. Now when the current comes to junction, it splits into the parts. So I1 amount of current passes through the R1 and I2 amount of current passes through the R2 resistance. Now we will apply to the resultant resistance when the resistors are connected in parallel connection. The formula is 1 by Rp, it is equal to 1 by R1 plus 1 by R2 plus 1 by R3 plus so on plus 1 by Rn. Here we have taken two resistors, so we can write the resultant resistance 1 by Rp is equal to 1 by R1 plus 1 by R2. Now we have to take the LCM of R1 R2. So 1 by Rp, it is equal to LCM of R1 R2, it is equal to R1 into R2. Now the denominator of first fraction is R1. R1 cancel. That means R2 times cancel in R1 R2. Here the numerator is 1 into, so R1 R2 times cancel. So 1 into R2. And here the plus symbol, so write the plus as it is. And here the denominator of second fraction is R2. This R2 cancel. That means this R2 R1 times cancel in R1 R2. So here the numerator is 1. So 1 into R1. So if you simplify this, 1 into R2 means R2 plus 1 into R1 means R1 by R1 R2. This is equal to R1 plus R2. We can write it as R1 plus R2 by R1 R2. This is 1 by Rp. So we want resultant resistance or total resistance, that is Rp. So this is, we got the value 1 by Rp. So we have to take the reciprocal of this value. Then it is equal to Rp is equal to reciprocal of this R1 plus R2 by R1 R2. It is equal to R1 R2 by R1 plus R2. So this is the final resistance or resultant resistance or equivalent resistance when two resistors are connected in parallel, that is Rp is equal to R1 R2 by R1 plus R2. So I think you understood this concept. Like, share and subscribe the channel to support. Thank you.